Am I audible? Okay, thank you, Kamlesh. uh, Unfortunately, majority of the students have answered this question wrong. I am sharing the results of the question. The question is about the enthalpy of dry saturated steam compared with the enthalpy of saturated water. Okay. So we were discussing the temperature and in the last lecture, and I had consider one example of heating of water at atmospheric pressure. Okay. So with reference to that, I had asked you this question. Unfortunately, the answers are not very encouraging. Let me go to the, let me close this poll first, and then we would take up the discussion. Okay. I'm closing the poll and sharing the results with you. So as you see that I had asked you whether the enthalpy of dry saturated steam is greater or saturated water is greater at a given pressure. Okay, when you heat the water, okay, at a given pressure, as I said in the last lecture, it will first sensibly heat itself, means there would be increase in its temperature. So water would experience change in the temperature. There will be increase in the change in temperature on heating. That is called a sensible heating. Water would become saturated. Saturated water means the water which is about to boil. And if you heat it further, then there would be a phase change. There would be a phase change, and the water becomes dry saturated steam. So obviously, the enthalpy of dry saturated steam would be more than the enthalpy of saturated water, not less than. Okay. So only 40% of the students have understood this. The remaining 60%, they have not understood this. That the enthalpy obviously of the steam has to be more than that of water, because for converting the water to steam, you need to add certain heat, right? There has to be heat transfer to the working fluid. Okay, so let me hide this poll. So the correct answer is false. The correct answer is that the enthalpy of dry saturated steam is more than that of saturated water at a given pressure. Okay. Let me hide this and go to the next poll. Hopefully now, maybe a number of students would get it correct. Now this question is about comparing a dry saturated steam with the superheated steam. Dry saturated steam with the superheated steam at a given pressure. So let me close this poll now and let me show you the answer. The question is about comparing the enthalpy of dry saturated steam and superheated steam. What is superheated steam? Superheated steam is a steam whose temperature is greater than the saturation temperature. That is the meaning of superheated steam. Okay, now in the process of heating, which I had demonstrated, using the temperature enthalpy diagram, I talked about the heating of water from a state A to state B, which is a sensible heating, followed by a phase change, and then the steam becomes dry saturated, and if it is heated further, it becomes superheated steam. Okay, so obviously, let me close this poll and show you the answers. I'm closing this poll and I'm sharing the results with you. So you see that again, majority of the students have answered it wrong. Okay, so my understanding is that only 30 to 40% of the class is appreciating this concept about the heating process which I had shown you on the temperature enthalpy diagram. Okay, so note that when you are heating the water, okay, and let me close this, and so let me tell the correct answer is what? Correct answer is enthalpy of superheated steam is more than enthalpy of dry saturated steam. Okay, and not the otherwise. So the option should have been false, which 40% of the students have guessed it correctly. Okay, so I'm hiding this and I will now try to show the whiteboard. Okay, so now let me again explain you what I was discussed. Okay, and hopefully maybe that number which was now 40%, that would increase a bit. Okay, I'm not very optimistic of convincing the entire 100% of the class, because in the online mode it is very difficult, especially if the students are simply logged in, okay, just for attendance sake. So as you see on the board, I had drawn the temperature enthalpy diagram. Okay, what I have drawn is the temperature enthalpy diagram, and let me show you the enthalpy of dry saturated steam, sorry, enthalpy of saturated water or saturated liquid on this. So this point, okay, which if I draw vertical, I'm choosing a red here. If I draw vertical from B, okay, if I draw vertical from B on the x-axis, because x-axis is now the enthalpy, so this point enthalpy at B is your HF. HF means the enthalpy of saturated liquid. Okay, note that HF means enthalpy of saturated liquid. Saturated liquid. This is HF. Okay, so on the temperature enthalpy diagram, this this portion which is shown by the arrows, this is HF value. So this is HF. Okay, from the origin to this point B, okay, from the origin to this point B, this length would represent the enthalpy of saturated liquid HF at a given pressure. Okay, for a given pressure, and for this example I had taken the given pressure to be a standard atmospheric pressure. Right, now if you heat this water, okay, if you heat this water, the enthalpy would increase from HB to HC. Okay, if you heat this water, the enthalpy would increase from HB to HC. So this is C, and this portion, let me choose some other color for this. I'm choosing blue. So this portion, okay, this portion which is shown in blue, okay, what is this? Can you answer, somebody? What is this HB minus HC? Or this portion which is shown in blue, what is it? Any answers from your side? Can somebody answer? No, that is all right. It is boiling. But what in terms of enthalpy I'm asking? Gargi, you are right. It is boiling. But in terms of enthalpy, what it is? Yeah, correct, Yuvraj, you are right. That is the latent heat of vaporization. That is the, yes, Ganesh, you are right. Ganesh, Neha, Yuvraj, they have answered it correctly. Kamlesh, it is not the enthalpy of saturated stream. That portion which is HB, HC minus HB is the latent heat of vaporization. Okay, it is the latent heat of vaporization. So I would be using for latent heat of vaporization, I would be using the term HFG. HFG. Okay, for latent heat of vaporization, I would be using the term HFG. And let me choose another color now. Let me choose a yellow. So this portion, now this, let me ask you, what is HC which is shown in yellow? What is HC which is shown in yellow? HC, okay. What is that HC? HF is the enthalpy of saturated water. HFG is the latent heat of vaporization. What is HC on my diagram? On my diagram, what is HC? That is from the origin up to C. What is that value? Kamlesh? Pranav, yeah, you are right. No, Gargi, it is not work. We are not talking about work anywhere. How come you got this work thing? We are talking about enthalpy. Okay, Rushali is right. Rushali and Pranav are right. It is basically, no. Rushali, it is not right. Rushali, what you have written is enthalpy of saturated liquid. That is incorrect. Pranav has answered it correctly. And earlier Kamlesh was to answer. Uh, it is enthalpy of dry saturated steam. Okay. It is enthalpy of dry saturated steam. Getting it? So what is H HC? So instead of HC, I would be using the term HG. Okay. So this HG means actually this entire yellow portion length. Okay. This entire yellow portion length, which is HG or HC. This HG is called as enthalpy of dry saturated steam, because obviously the state C is the dry saturated steam. So enthalpy of dry saturated steam. Yes, is this clear now? Hg is the enthalpy of dry saturated steam. Okay. And hd, what would be hd? Suppose this is your d. Let me choose black now. Let me choose black for this, the hd. So what is hd? So this is hd. Okay. So what is hd then? hd is what? Enthalpy hd. Yeah, correct. Jayesh is right. Jay, you are right. Neha, you are right. So HD is obviously, as most of you are answering it correctly. Jayesh, Jay, Neha. It is the enthalpy of superheated steam. It is the enthalpy of superheated steam. Right? I hope this is clear to you. It is the enthalpy of superheated steam. Now you can figure out the question which I had asked in the poll questions. You can figure out that enthalpy of superheated steam is greater than enthalpy of super, yes, correct, Kunal, you are right. Enthalpy of superheated steam is greater than enthalpy of dry saturated steam. Enthalpy of dry saturated steam is greater than enthalpy of saturated liquid. Okay, right? So just to check whether you have understood this, I have another poll question. Just to check whether you have understood this, I have another poll question. So let me ask this poll question. So I want all of you to vote. Those who are attending this class, all of you should vote so that I understand whether you are really following this concept or not. So up to now, only 40% of the students have voted. We have 120 students attending this class. So only 60% of the students have voted. I want all of you to vote. %63 of the students have voted. So roughly speaking, if you look at the numbers, at least 50 students have understood, 70 students have voted, and 90% of the students have voted it correctly. Okay. So it's good enough that at least 60 students have understood this concept. Okay, I'm closing the poll. Okay, and showing you the results. So let me close the poll and share with you the results. So as you see that 90% of the students have correctly answered this, that Hg minus Hf is HFG, latent heat of vaporization. Okay, Hg minus Hf is HFG, which is latent heat of vaporization. So let me close this. I'm hiding this now, and let me go to the sheet. Okay, so let me take a blank sheet now. So I will just write down this understanding which you have gained on the board again, once again. Okay, so let me write it with red. So Hg minus Hf is Hfg, which is latent heat of vaporization. Latent heat of vaporization at a given pressure. Obviously, this is at a given pressure. Hg is the enthalpy of dry saturated steam. Hf is enthalpy of saturated liquid. And Hfg is the latent heat. So rewriting this, you can say that Hg, if you want to calculate, then it is Hf plus Hfg. If you have the steam tables, okay, if you have the steam tables, so tell me the value of from your steam tables at 1.013 bar, or approximately at 100 degrees centigrade. You tell me the values of Hf, HFG and HG from your steam tables. Okay, either offline or online steam tables. If you are using, you just write your names while you put down the answers in the questions column. Okay, tell me the value of HF, HFG and HG from the steam tables. Kunal, Neha, Jay, I hope that students have purchased the steam tables. Yesterday few of you have mentioned that you have bought the steam tables. Okay, so hopefully you have the steam tables now with you. And those who have the steam tables, you please tell me the value of HF, HFG and HG from the steam table at 100 degrees centigrade. That they are standard atmospheric pressure. HF is what? HF is the enthalpy of saturated liquid. HG is what? HG is the enthalpy of dry saturated steam, and HFG is the latent heat of vaporization. So please tell me the value of enthalpy of saturated liquid. Okay, Kunal has given me some answer. So Kunal, Pranav has given me some answer. So you can figure it out that about 419 is this value, about 2258 is this value, and if I add this two, okay, so around 26, if you add this, maybe you will get around this 2676 or 2677, whatever. So this you can always cross check. Okay, you can take any pressure and you can convince yourselves. You can check any pressure. You can take 10 bar pressure, you can take 100 bar pressure, and you can convince yourself that Hg minus Hf is always Hfg, or Hf plus Hfg is always Hg. Yes or no? Kunal, Pranav, is this right? Tell me the value at 10 bar, Kunal. 10 bar. 10 bar, what is the value of Hf and what is the value of Hfg, and whether that comes to be equals to Hg. At 10 bar, tell me the value of Hf, Hfg and Hg. Pranav. Those who have the steam tables, please tell me these values. See, I am again telling you that it is a good idea to purchase steam tables from the market. Okay, or if you are not physically able to locate that, or if it is not available in the market, get it photocopied. And the worst case scenario, use online steam table. Worst case scenario, use the online steam table. But you must be now looking for the values from the steam tables. Okay, please start looking for the values from the steam tables, because it is very important for you from the learning perspective as well as from the examination perspective. So Pranav, you are given the value of Hf. I want Hfg also. Kunal, Pranav, Neha, Jay, Jayesh. Okay, Kunal has given me the answers, so I'll just write down those answers. So I'm writing approximate values. Okay, so approximately I'm putting the values. Gaurav has also given me the value. Yes, Gaurav, thank you. So approximately I am putting the values 2014 approximately. I'm rounding it off and putting the values. So you can convince yourselves that Hf plus Hfg is always Hg. Okay, Gaurav, thanks. Pranav, thanks. Kunal, thank you very much. Okay. Yes, Gunjan, thank you. Similarly, at 100 bar also, now I want the values at 100 bar. Tell me the values at 100 bar also. Tell me the values of Hf, Hfg and Hg at 100 bar. This was at 10 bar. Similarly, at 100 bar, you tell me the values. At 100 bar, you tell me the values. HF value, HFG value, and HG value at 100 bar from the steam tables. Okay, Gunjan has given me the values. So HF value is approximately around 1408. Nikhil, thank you. Gunjan, thank you. HFG value is around 1317, 1319, whatever. I'll just round it off to 1320. And HG value is around 27. 2727, okay, 2727, whatever. So yeah, Nikhil, thank you. So as the students are reporting the values you see now, similarly I'll just put one more exercise. At 221 bar you tell me the values. 221 bar you tell me the value of HF, HFG and HG. HF, HFG and HG, you tell me the value at 221 bar. And you'll get very interesting insights from this after you tell me these values. Then I will have a discussion on what is called as a temperature enthalpy diagram. Two 21 bar, Yash More. No, you are 100 bar. You are giving Yash More. Okay, Kunal has given me the answer for 221 bar. His values for HF is 2107. Value of HFG is 0, and value of HG is also 2107. Okay. So now, yes, Gunjan, thank you. So now let me discuss this a bit. Okay, let me discuss this a bit. If you look at the HF value, this is the HF value at 1 bar. Okay, this is the HF value at 10 bar. 10 bar. This is the HF value at 100 bar. And this is the HF value at 221 bar. So what do you feel? What do you say regarding the HF value? As you go on increasing the pressure, what happens to the HF value? But obvious, what happens to the HF value? As you go on increasing the pressure, the enthalpy also increases. The enthalpy HF means what? Pranav, what is HF? What is HF? Yeah, correct. HF is the enthalpy of saturated liquid. Neha, what is 1? Why you have put 1 HF value as 1? Neha, it is wrong. The HF is enthalpy of saturated liquid. So what it means is that, Shubham, right, correct. What it means is that if you go on increasing the pressure, okay, at which you are heating the water, right, the amount of enthalpy required for attaining a saturated liquid would be more. Okay, all right, Neha, thank you. So with the increase in the pressure, the enthalpy of the saturated liquid or the heat required for the water to become saturated, the heat required for the water to become saturated would increase with increasing in the pressure. Okay, so if I want to draw the diagram now, I will be constructing the diagram now, plotting HF for different pressures. Okay, so let me plot this HF value with respect to temperature or pressure. Okay, now what you'll find is that this HF value would go on increasing. Okay, it would go on increasing, and you'll find that suppose this was the HF value earlier, now it becomes this, now it becomes this, and finally this. Okay, so at 221 bar, right, this is at, let us say, 100 bar, let us say this is at 10 bar, and let us say this is at 1 bar. Okay, so we find that the HF value, okay, the HF value would go on increasing. The HF value would go on increasing, right? So if I connect it this way, all the HF values, if I connect, okay, if I connect all these HF values, just excuse me for the deviation, I'm not able to correctly plot it on the whiteboard, but assume that these points are here, these points are here. Okay, so these points, if I connect all the HF values, if I connect, that gives me a curve which is called as a saturated liquid line. This is called as saturated liquid line. Okay, so this pressure is say 1 bar. Okay, so if you consider heating of water, okay, heating of water at 1 bar, then you get certain value of HF. That value you had already told me, that value at 1 bar is around 419. At 10 bar it becomes 762. At 10 bar it becomes 762. So it is 419, and at 10 bar it becomes 762. You find that it goes on increasing, the HF value goes on increasing, right? And now this is the nature of the curve. This is the nature of the curve. It is called a saturated liquid line. Now what happens at 221 bar is interesting. Okay, but before that, let me show you the HFG value. What happens to the HFG value? What happens to the HFG value, Urshali? As you go on increasing the pressure, what happens to the HFG value? Have a look at the numbers which you are given to me. HFG at 1 bar is 2258. HFG at 10 bar, yes, Kunal, it is right, it decreases. HFG at 10 bar has decreased from 2258 to 2014. At 100 bar, it decreases further to 1320. Yes, Maheshwari, you are right. And finally at 221 bar, the latent heat of vaporization becomes zero. Okay, so that 221 bar, there is no boiling. The meaning of this is there is no boiling at 221 bar, and that pressure and the corresponding temperature is called as a critical point. Okay, is called as a critical point. So let me draw this HFG lines on this temperature enthalpy diagram or pressure enthalpy diagram. So this, let us say that this is your HFG at 1 bar, then your HFG value decreases, it decreases further, and finally it becomes zero. And this, suppose this is A, or suppose this is F, and this is G. Okay, F, this is G. Suppose this is F dash, and this is G dash. This is, let us say, F double dash, G double dash. Okay, and this point you'll find that F and G, they are going to overlap, and the meaning is that this HFG value goes on reducing with the increase in the pressure, and finally at a critical point we will find that the HFG value becomes zero. There is no boiling. Okay, so this line which I am now drawing, this curve, okay, which I am now drawing as a loci of the points G, G dash, G double dash, this curve is called as saturated gas line. This curve is called as saturated gas line, or you can also call it as dry saturated vapor line. Okay, or simply you can call it as G line. And what you get is, as the outcome, what you get is the vapor dome. So this is a vapor dome. It's a very important dome. This vapor dome which I had drawn gives you an understanding of the behavior of steam, especially when you consider practical applications like power plants, okay, wherein you are using the water steam combination as a working fluid, right? So here you find that as you go on increasing the pressure, suppose you take a boiler, if you take a boiler which is operating at 1 bar, okay, what information you get from this is that the boiler, if you use at 1 bar, you will require around 411 kilojoules of heat to convert it into saturated liquid. Then you would require around, let me check the values, put the values, it is 2 to 58 kilojoules per kg for phase transformation, and finally you will get dry saturated steam. If you go to a 10 bar boiler, if you choose a 10 bar boiler, right, then for getting a saturated liquid, you will require the water would have an enthalpy of 762, and for phase transformation it will require another 2000. So this would be 2000. If you operate at a still higher pressure at 100 bar, then you see that the enthalpy HFG value is only 1320, right? So let me go to this. This is 1320, and finally there is no boiling. So this boilers, if you choose a boiler which is operating, this is called as a critical point. Can somebody tell me the temperature corresponding to 221 bar? Maheshwari, can you tell me the critical temperature the critical pressure is 221 bar. So from the steam table, tell me the corresponding temperature. Yes, Kunal, you are right. So the critical temperature is 374.14. Critical pressure, what is the unit of that? Yeah. What is the unit of that? 374.14. Obviously, the unit is, what is the unit? Degree Celsius, right? Obviously, the unit is degree Celsius, and this you need to understand that if you design a boiler which is operating at a critical temperature or a critical pressure, then what you'll get is that boiler no longer is a boiler. The boiler is no longer a boiler. It means that it can be called as a steam generator without boiling. Means you generate steam without boiling, meaning that what happens in that machine is the water would flash itself to steam. So there will be flashing. There is no boiling. See, boiling, you understand that when you are talking about boiling, you will have first 100% water, then you will have wet steam, and then finally dry steam. That is what is boiling, right? In the boiling process, what you get is you get a saturated liquid, then you get a wet steam, and then dry steam, right? That is what is boiling. When you go to a critical point, you don't have dry steam, you have saturated liquid, and suddenly you have the dry saturated steam. Okay, so there is no boiling. So this you have to understand that in market now you will find that the boilers, some boilers are operating above 221 bar pressure, so they are called as supercritical boilers. The boilers which operate below 221 bar, they are called as subcritical boilers, right? So this you have to understand. So when you study the different types of boilers, as was explained to you in the theory portion where boilers were covered, you understood that there were some boilers which were operating at much higher pressure. So you must be now, when you look at some boiler, any boiler if you come across, you should be interested in knowing what is the pressure of the boiler. Okay, you must be interested in knowing what pressure is the design pressure, what design pressure is the boiler, and whether that boiler is a subcritical boiler or supercritical boiler. Okay, as I told you that people now no longer use the term boilers because you might generate a steam without boiling, right? So now boiler can sometimes be a misnomer, especially when you are talking about steam generators operating above the critical point. Okay, so what is critical point? Critical point is a point, okay, it is a temperature and pressure for steam to be formed without boiling, or in other words, the latent heat of vaporization is zero at critical point. The latent heat of vaporization is zero above the at the critical point, right? This you have to understand. Okay, so as you see on the vapor dome, you look, it is a dome like structure. When you plot the properties on a temperature enthalpy diagram or even temperature entropy diagram, you will find that you would get a dome like structure. Okay, now let me ask you one question. Okay, tell me, if I ask you, tell me the enthalpy of steam, enthalpy of steam at 10 bar. Can somebody tell me? Tell me the enthalpy of steam at 10 bar. Enthalpy of steam at 10 bar. Kunal, Neha, Kamlesh, Maheshwari, Rushali, Shubham. Gargi is offline. Pranav, Gunjan, Yash More, Nikhil Pardeshi, Gunjan Sarode. Anybody? Tell me the enthalpy of steam at 10 bar. The answers are not coming. Tell me the enthalpy of steam at 10 bar. Kunal is giving the answer as 2776. Neha is also giving me that same answer. Now, Pranav is also giving me the same answer. Now, all the three are wrong. Why they are wrong? Let me tell you. It is not because you don't know how to look at the steam tables. It is just a question which has been designed to confuse you. Okay, when I'm asking you enthalpy of steam at 10 bar, okay, enthalpy of steam at 10 bar, then what you are doing is that you are looking for the values. Suppose this is a 10 bar pressure line. 10 bar pressure line. This is a 10 bar pressure line. Okay. So when I'm asking you the enthalpy of steam at 10 bar, you are assuming that the steam is dry saturated. In all your answers, you are assuming that the steam is dry saturated. Okay. Let me ask you this question, that suppose this is G. Okay. Let me ask you this question, whether the state B is not the steam at 10 bar, whether state B is not steam at 10 bar. Yes or no? Whether the state B is, or let me ask it like this, whether state B is a steam at 10 bar. Yes or no? Whether state B is a steam at 10 bar. Yes or no? It is, but we have to multiply with the steam fraction. Yes, but wet steam, right? Yes. So when I'm saying that you have to find enthalpy of steam at 10 bar, then you need to ask me a question. You need to ask me a question whether the steam is dry or wet. Whether the steam is dry or wet. If it is dry, obviously the answers given by you three, it is correct. If it is dry steam, then obviously we need to look for the value of Hg from the steam tables. But if it is a wet steam, then you must know how much dry the steam is. Okay, so for that, there is a parameter called as dryness fraction. That is a parameter called as dryness fraction. So what does dryness fraction tell you? Dryness fraction tells you how dry the steam is. So what is the dryness fraction at G? The dryness fraction at G is 1. Dryness fraction at G is 1. And what is the dryness fraction at F? It is 0. The dryness fraction at F is 0. And midway, this dryness fraction would have any value between 0 and 1. Okay, so if I say now that find the enthalpy of steam at 10 bar, which is 80% dry. Find the enthalpy of steam at 10 bar, which is 80% dry. Which is 80% dry. So how will you find it out? How will you find it out? So for finding it, if you look at this graph carefully and study this, I need to find out this H of steam at B. And I know that its dryness fraction is 80%. It means that H of dry steam, wet steam would be HF, that is this HF, plus X times of Hg minus HF, or HFG. Okay, are you getting this point? H weight is HF plus X into HFG. So the answer would be, for this problem, HF at 10 bar, you'll have to find HF at 10 bar plus HF at 10 bar value you'll have to find plus 0.8 into HFG at 10 bar. So find the answer and tell me. Find the answer of enthalpy of wet steam, which is 80% dry. From the steam tables, you please tell me the values of HF at 10 bar, HFG at 10 bar, multiply 0.8 with HFG and figure out what is the enthalpy of wet steam. Neha Aire, Shubham Hande, Pranav Mate, Vrushali, Chinmayi. Kunal, Kamlesh, Maheshwari. Yash More is offline. Gunjan is offline. Nagare, Gaurav, Jay, Jayesh. Yuvraj Singh is offline. Sharwar is offline. Or whatever. So Neha has given me the answer. I just want others to check that answer. How to find that answer? First, find the value of HF at 10 bar. Find the value of HFG at 10 bar. Multiply that HFG with 0.8. HFG with 0.8 and add it to the value of HF at 10 bar. Sharwari is giving some answers. Sharwari, kaitri chukla hai. Nikhil, Pranav. So tell me what is the value of HF at 10 bar? We had already found out that value, no? HF at 10 bar, we have that number. It is 762. And HFG is how much? Pranav? HFG कितनी है? 2013. Okay. 762 and 2013. So this is 762. HF is 762. This is 2013. Multiply this with 0.8 and add to 762. You'll get the value of enthalpy of wet steam. Okay. I hope this is clear to you. Is this clear? Is this clear for all? See the students who are, yes, प्रणवला समजलाय पण सर्वांना समजलाय का? कमलेश जे उत्तर देत आहेत त्यांना समजलंय याच्याबद्दल मला काही शंका नाही आहे. But the students who are not answering, maybe because of some issues. Saurabh is saying yes. जे उत्तर देत नाहीत त्यांनी पण yes म्हणावं म्हणजे मला बरं वाटेल. Chinmay is saying yes. Saurabh is saying, Ganesh is saying yes. Sridhar Kathal is saying yes. Okay. तेजस ने यस म्हणाला. अरे वा, नवीन नवीन नाव मला समजतायत. तेजस, श्रीधर, गौरव नागरे saying yes. Aniket is saying yes. Sharbar is saying yes. Others? Sanket Sanap is saying yes. Durgesh Birar is saying yes. Anamta, I need little more practice. Don't worry, we'll have a lot of practice, Anamta. So exams are not around, so don't worry about it, Anamta. Kunal Patil is saying yes. Okay, this is Kunal Patil, not Ranade. Okay. Kunal Sravan Patil is saying yes. Jai Kabir, okay, Kabir Gangavane is saying yes. So nice to see some unknown names also. Kabir, it is a nice name, Kabir, you have. You are a Sufi saint, Kabir. All right, I will assume that. Okay, we will have few more uh, practice exercises. Don't worry about it. So even if you have not understood it, we will do it in more rigor next time. Okay, so thanks for being online. Hope you have enjoyed the lecture. I'm ending this webinar. Thank you very much. Bye for now. Thanks, Shubham. Thanks, Tejas, Anamta. Thank you.